Welcome. In this video I'm going to show you how you can perform a post-hoc residual analysis after a goodness of fit test using binary tests and Python. I'm actually using Python version 3.12 at the moment, and this is something you could therefore do after a goodness of fit test. And you want to compare the observed counts with the actual or with the expected counts from each category. You could also do a pairwise test, but I have separate videos on those if you want to compare each category with each other. To show you how this can be done, I'll need some example data, so I'll first load in pandas and then the General Social Survey from 2012 adjusted for some example purposes. I don't need all its data, I just need one nominal field, so I'm going to store under nominal field mar1, which is the marital status, to give you a quick impression. The value count showed that, for example, 79 people indicated to be separated. I actually have my own library that already has a function that can do all the work for us. I have a separate video on where I show you how that works, but here is what that would look like. In this video I'm going to not use that. I'm actually going to not even use panda, so I'm going to convert my panda series to a list. Remove any of the missing values by saying it's not equal to not a number. And then the first thing I need is all the different categories. So what I'm going to do is I'm going to actually store the categories as a set from the data, because the set will remove any of the duplicate values. We need to know how often each of these actually occurs, so I'll simply create a dictionary where the key is then going to be the category name, and then it's simply going to count how often each of those occurs. So indeed there's that 79 for separated. I'm going to use some expected counts, 300 for divorced, 280 for never married, but you could also just simply use the same for each category if you don't have expected counts predefined. Now we can perform any of our sample binary tests, so for example a binomial test, but you can see the documentation for each of the other ones if you like. So here I have the binomial test from SciPy If you don't want to use a library for this, see the videos on the one sample binomial test on how you could do it without. I need the number of categories, the sample size, and then I'm simply actually going to iterate over all possible categories, get its observed count, its expected count, and then perform the binomial test and print the results. And that should give us now nicely for separated. I get the significance and the adjusted significance, which is Bonferroni corrected, which is actually simply the p-value times the number of tests that we're doing, which in this case will be just the number of categories. Unless it's above 1, then it should just report a 1. As you can see, it looks like none of them are significant except for, let's see, this one seems to be below the 0.05 threshold, which is the usual threshold, and this one as well. So never married and married seem to be the two categories that have a significantly different amount count than what was expected. If you want to do the residual test, there is residual and standardized residuals and adjusted standardized residuals. This actually is simply taking the difference between the observed and the expected count and divided by the square root of the expected count. That's then treated as a Z statistic, so we can use the standard normal distribution. So similar as before, we do the exact same thing, but now instead of doing a binomial test, we use the normal distribution on our Z values. And that should give us somewhat similar results. As you can see, again, never married and married are below the 0.05 threshold, and there's 3 zeros after the decimal separator here. Alright, well, I hope this gives you an idea of how you could perform this. and I hope this video was helpful. Thank you for watching.